Good afternoon, everyone. I hope you guys are all having a really great IMARC. I certainly am. As you've heard, my name is Meheroop Chopra. I am the head of green power at Fortescue, decarbonization. And I'm personally really excited to talk to you guys, being a chemical engineer and talking about power station design. I think I'm really looking forward to that. And my journey with Fortescue began almost 3 years ago. Really in a technical space within the hydrogen system before I moved into working on what is today Fortescue's flagship project, which is our Real Zero target by 2030. Before I continue, something personal about myself. When I'm not working, I do love to read books and I do love to watch movies. And ironically, one of my favorite movies is called Mission Impossible. And as I do speak to a number of people, sometimes I feel that that's what I get back when I tell them that we're about to spend $6.2 billion by 2030 to decarbonize ourselves completely of Scope 1 and Scope 2 terrestrial emissions from our iron ore operations. I wouldn't go as far as saying impossible. I might settle on difficult, but that's how I feel at the moment. I'd love to start telling you, before I go into more detail on the power system, I want to tell you a little bit more about Fortescue. So almost 20 years ago, we started from a really small organization to now being one of the largest iron ore producers in the world. We carry significant ambition in being a green energy provider, in being a technology provider for green technologies, and obviously to continue to develop and grow our mining business. And this is all really important because Fortescue is known to be an ambitious organization and a progressive organization. But when you try to distill it down into trying to solve the problem, which is how do I go and take all of this information and start to implement it into a power system? You start to think about what are the key things that you would consider out of this entire big umbrella of what Fortescue wants to do to be able to start to design what it is that Fortescue needs to go to from a power perspective. So here are some of the early considerations that we started to give, right? So our earliest considerations were, let's look at production considerations. So we produce about 200 million tons of iron ore every year. We move significantly more material to be able to get there. So we're talking anything between 500 to 600 million tons of materials moved. We have to consider the products that we supply. We look at hematite, we look at magnetite. They're all different in the way we process them and the energy requirements of both of them. We also start taking into account the geographic locations of all of our operations, because that begins to tell us what sort of system we need to have. Am I going to connect it to a grid? Am I not going to connect it to a grid? Am I going to be transmission lines? What am I going to do? We also then start to consider things such as what is the current energy use and what is the current energy mix. We already are a hybrid power system in Fortescue. We run off gas, we run off diesel, and we've just got a new solar farm that we finished commissioning. To top all of that off, there's infrastructure to think about. So what infrastructure do we own? What infrastructure are we going to build, right? At the moment, we've got transmission network that is not completely there. We've got some of our mining centers connected, but not all of them. How do we connect those up? Do we connect them up to build some contingency into them? Do we connect it up for more space on that network? What do we really do? So I guess this development journey started off by having a look at all of those plus more considerations and then working out what does that actually mean when we start to design something, right? So when I look at this slide, the first thing I'll say is all of these things are important, but the most important thing is to understand your load. Okay, so whether you're a customer, whether you're doing it for yourself, understand your load. What is the problem that you're trying to solve? We could be looking at finding a non-emitting renewable energy source, definitely. We do want to find ways that we can dispatch energy. You may have heard this from Fortescue a number of times. We'll produce when the sun is shining, we'll produce when the wind is blowing, but we also need to produce when the sun is not shining and when the wind is not blowing, right? So we need to understand, how do you use energy? How do you store energy? How do you dispatch energy? You have to couple all of that and really trying to understand what your operations are about. So we have to understand our operations, right? What flexibility do we have in our operations? Where do we go in terms of how we operate? What is the mindset of the people? What is the physical constraints and equipment that we already have on site? But most importantly, coupled with all the technical, we need to look at some of the non-technical aspects, such as who are the people we've got and how do we bring people along the journey, right? Because you can design, technically, you can design a really good power system, but having collaborative internal partnerships really helps you understand what is happening on site and where do you really need to focus some of your dispatch, where do you need to satisfy unique demands, and where can you really build flexibility within that system. And we have to do all of that while still meeting our safety, cost, and production targets, because at the end of the day, we're still a business, right? So once we started to define a lot of these aspects and areas, and our load was almost anywhere between 650 to 750 megawatts, we started to think about what are the options that we've got. Now, anyone will tell you that it would be really great if you could have a single source of energy that would provide you with the power whenever you need it. And a lot of us are used to that right now, yeah? So most mining businesses, they'd love to get energy when they need energy, right? Nothing should challenge production. The only way you can get some of that energy is if you have hydro or you have geo, which we don't have in Western Australia. So we have no other choice but to go for a hybrid system or continue down the route of a hybrid system. So, we started then say, okay, we have to do it with wind, we have to do it with solar. We're going to need dispatchable energy, so we need batteries. We're going to have to think about, the periods of intermittency that we're going to have, and is that enough? We have power stations. What do we do with the power station? So how are we going to do this? And at the end of the day, we still want to be able to make sure that the grid, whether it's off-grid or whether it's connected to a public grid, it needs to be resilient, it needs to be reliable, it needs to have redundancy, and it needs to be able to supply the energy that we need while maintaining a very good levelized cost of electricity. So that is really what our operations look like in the Pilbara. So when we started to take all of these high-level thoughts, we started to look at how do we distill that information into something that we can develop that is going to solve that problem for us. Okay? So then we started to look at, if you're going to have solar farms and we're going to have wind farms, how are you actually going to find the right locations for these? And I think many of us, if you've heard some of the previous presentations, sometimes you don't pick the most optimized location because that's the best location. You pick the location that's available to you, right? So we've had to try to find a balance between where is it that we have good relationships, where can we actually access land, right? Maybe it's not the best, but it's something that we want to be able to do to be able to meet what we need to do in 2030. Then we start to look at what is the size that you can fit in those locations, because sometimes you may be at a really good spot, but you only have enough land to put a certain amount of renewable in it, and you can't put more than that. So we need to balance the size, and we need to balance the location. And for us, because we have a power station and Fortescue does have ambitions around green molecules, how do we actually integrate green molecules into these solutions? And then more importantly, from there onwards, let's start to look at how do we distribute all of this to be able to meet the demand and to be able to meet all of our mining centers. So for example, you can see on that map over there, wind doesn't have a lot of good locations. It's got some really good locations that you can go to, but we ended up typically having a single wind location, but we distributed our solar because I don't think you can get better than the Pilbara when it comes to solar, right? So, you really can't go wrong where you put the solar. We have tried our best to make sure that our mining centers are complementary with our solar farms so that we can provide a certain level of availability and stability and resilience to that grid. And then we're looking to see how we can couple our batteries and the rest of that infrastructure to be able to give you a coherent design. But as we're doing this, data is really important, right? So wind data, your solar data, what does that look like? how complementary are those two sources of energy, if you want to call it. Now, for us in the Pilbara, they're actually quite complementary. So wind and solar really work with each other quite well. When the sun does stop shining, the wind does start blowing, which is great for most of the time. So we started to collect all of that information, and the first thing you do is you put it into a techno-economic model, and you hope that you get a really good answer out of it, right? I'm not going to go into how the techno-economic model was developed. There are some proprietary techno-economic models that you can use. But essentially, it spits out something that looks like that. Now, this was a very interesting phenomena for us. This is a typical month that you could have in the Pilbara, right, where you have wind and where you have solar. If you look on that side, you could have some really, really great days where your wind is blowing and your sun is shining and you have significant amount of energy that you don't use, your batteries are charged, everything is great. Fast forward another 6 or 7 days, or you'll find out that the wind is not blowing as much, the sun is not shining as much, and all of a sudden you need something to supplement that energy that you're going to have. Now, it's very interesting, and when we're looking at it, you actually spill 44 gigawatt hours of energy when you have a deficit of 20 just a few days later. So when you look at this, you can draw many conclusions. One, have you undersized your system? Do you need to build more energy storage? Do you want to try to capture that 44 gigawatts as much as you can? What do? Do you stop here and say, we'll just capture that and move on? Or do you start to think about what more can you do? Because at the end of the day, that could be 1 month in 10 years, right? And the next year, it wouldn't look like that. So you don't want to overinvest either. Which is where demand begins to come in. So understanding flexibility in your business, understanding how you can do things differently. When do you turn around? When do you take breaks, right? How do you stockpile differently so you can have, what you call mechanical battery available so you can move product? Because at the end of the day, moving product is the most important thing. But really, really looking at the demand side of things and understanding your demand and bringing flexibility into demand actually helps a lot more than just overbuilding your system. Because at the end of the day, these systems occupy a lot of land. You don't want to overbuild because you're basically using land that you don't need to use. And in a sustainable world, we should all try not to do that. So we found that by focusing on demand and trying to manage and balance that the best we could with the supply that we've got, we're beginning to see some really good outcomes. We're beginning to see that you could really optimize that design even further. You don't end up with 44 gigawatt hours of wasted energy, but you don't also need 20 gigawatt hours when you need it, right? So you begin to really close that gap, and then you can optimize what sort of long duration energy storage or anything else that you need. And as modeling continues, I thought I'll put some of these graphs up because it's not as simple as just the first one you've got, but we start to look at how does the entire year go. We start to compare that against how the stockpiles in our business behave. We start to think about where do you want to put it, how do you want to manage your reserves. Some of these begin to tell you trends on how would you respond, how do you design the stability and the resilience of the system. All of this begins to tie up with each other. How do you use your OPFs? So essentially, as we've got more and more sophisticated, we've been able to use a lot more of this data to drive better optimized design. I am running out of time, but I think this is the one thing that I really wanted to talk about here was the power system is just one half of the equation, right? So you can design a really nice off-grid power station. We decided to keep ours off-grid because it reduces the amount of complexity that we have. We already have a complex system. We didn't want to have the added complexity of connecting it up to a residential system, for example, where there's a lot more control and a lot more regulation required. But ultimately, you need to look at it as an overall system. How do you optimize right from the generation all the way down to putting your product onto your ship? So I just wanted to say thank you. Thank you for listening. Hopefully some of this information has really helped you. There's been a really big theme on collaboration, and I think Fortescue as an organization, we believe that we do all need to collaborate, and we need to collaborate quickly to be able to get to where we want to get to. So I just wanted to, again, thank you very much, and have a good rest of IMARC. Thanks.